The problem of the day, one problem, and you get to practice, is going to be calculating how much tension is in each cable of those cranes, right? And please don't anyone tell me 7,500 pounds each, right? So it doesn't split down the middle, right? It's just we opened on day one of vectors. We said, okay, if we fill a bucket of water, let's say that's it's 5 gallons, 6 pounds per gallon. That's almost 30 pounds, right? It's easier to pick it up closer to your body than it is to pick it up fully arms extended. So it's all going to depend on angle and length and all things like that. So someone with longer arms is going to do more work than someone with short arms, right? So we've got this going on. So we've got the cables, the tension, all of that problem. So what we're going to do, so you're copying it, but I really need make sure you keep one ear open because I'm going to tell you about the whole problem. What we're going to do is we're going to turn it into a vector problem, and we're going to draw it out as a triangle, and we're going to use geometry 1 angles to calculate the magnitude of the resultant vector. All right, so it's got all those words, but we'll see as we go. All right, so I'm going to take that diagram, and I see you still kind of copying it, so I'm going to kind of shrink it up. We'll see what we can do as we get going. So I'll draw it off to the side. So what's the number one thing to understand is you can draw this in different ways. You can draw it up, down, whatever. Let's start with me doing one way to start with, and then you can manipulate as you get more experienced. So what is definitely no ifs, ands, or buts is that package. That is, let's just say it's a metal container come off of a truck, and it's going to go on to a ship, and the cranes are moving it. All right. So what we do know is gravity is pulling that object straight down. And the magnitude of that, the magnitude, so the length of that vector is it's being pulled 15,000 pounds. So we need to understand that that's a vector. So I'll go off we'll go down off the video and then off the screen for the video and then come back. So let's just pretend I asked you, pretend we were in algebra 1 and I said to you, here's an XY axis and this point is at -10, right? And it's on the Y axis. And I said, give me the X and Y coordinate of that. I want some voices. So what's the X coordinate of that? 0. And what's the Y coordinate? -10. Okay. So now we then come into pre-calc. And we say, all right, of course it doesn't work. There we go. And then we say, okay, well now it's a vector that's pointing straight down. So it has a horizontal and a vertical component. And it starts here and it ends here. So its vector component is right there. What's the direction right or left that vector is traveling? 0. Same thing, right? So it's 0. And then it went down, in our case, 50,000 units. So the same exact thing. So let's go over here. And do that. I'm trying to delete, sorry. Okay, let's go over here. So this vector is 0, -15,000. Now, these vectors, these lines right here, I'm pointing to this. I don't know if you can see me drawing over that right there. That vector is going to be, it has to be, depends how you draw it. I'm going to start from the top down. You can do from the bottom up. It depends how you've drawn it. You can think through. Everyone did on the last class. So this vector looks like that. So see how it looks exactly like the other vector. It's looking like this. Then the other vector, which looks like, I'll do it in green. So now I know it was drawn in red, but look, I'll put this one in green. It looks like that. So using our vector tip to tail, I'm going to put this vector, let's see if I can get that angle kind of right. I'm going to put that vector on there. So the concept, so we've been talking for a few minutes already. The concept is when you, from the beginning of the first vector, so there I'm drawing it right there, big solid red dot, to the end of the next vector, which is right there, they need to begin at the beginning of the weight vector and needs to end at the weight vector. So my tip to tail method needs to start here and end up there. Then my magnitude, which is the black line drawn, is going to be 15,000. So then we get into a little bit of complication because of what we need to do. So let's refresh after our break that let's call the tension. Let's call the length of this vector tension 1. You can call it X, you can call it V, you can call it whatever you want. But since we're talking about tension, I'm going to label it tension. So that means the magnitude or the length of that vector is tension. And then let's go to this vector, and the length of this vector is known as tension 2. Tension subscript 2. You can call it whatever you want. I don't care. So, couple of things to touch base with. So we are all familiar with, we find our x component by doing r cosine of theta, r sine theta. Okay, and if you're on this video and you're not sure about that, you need to speak to me because that's old stuff, right? We need to, so we've got r cosine theta, r sine theta. That's how we find our x and our y. Now, what we're going to do is we're going to change it to real life. So instead of calling it r, which is the radius, which is the magnitude, we're going to call it tension 1 cosine of theta, tension 1 sine of theta. But we know it's exactly the same thing. We know that these numbers are the same. Okay, they're the same. We just called them different things. So, and I'm going to do the same thing for the second vector. So it's going to be tension 2 cosine of theta, tension 2 sine of theta. So now we're going to have to go through and plug in some stuff. So let's look at our drawing up here, looking at this. So my left vector here, or my first vector, it is 43 degrees below the horizon, 43 degrees below the horizontal on the left-hand side. So in math, we call that quadrant 3. So that's 43 degrees below the horizon. So that's 43 degrees below 180. So that vector, so I'll do it in red so we know we're talking about the red vector. The red vector is tension 1 cosine of 223 degrees and tension 2 sine of 223 degrees. One more time, we're doing 223, because the direction the vector's pointing, to the left and down. It's in quadrant 3, and it's 43 degrees below the horizon. So now we're going to do the green vector. So the green vector is tension 2 cosine. Well, let's think about this one. This one is 32 degrees below the horizon. Actually, it's, well, technically, yeah, that's fine. It's 32. We'll call it that way. 32 degrees below the horizon. So that one, some people might say -3. What would that make it? -328. But I'm going to say, to keep it easy, I'm 32. There's no reason. It's coterminal. Doesn't matter what you do. And then I'm going to do T2. That's the tension in 2 times the sine of -32. All right. So now we're going to take a leap. So now we got it all set up. Okay. So go ahead. Yes, please. Because it shouldn't be. Thank you for noticing. Because I'm talking and not paying attention. Thank you very much. All right. Well done. So, okay. So, yes, it's definitely the tension on that times the cosine and sine respectively. So, do you see what he pointed out? I had tension 1, tension 2 on this vector, and it should have been, it's always going to be tension 1, tension 1, tension 2, tension 2. So, let's look. Now we've taken the drawing and we've gotten to this stage right here. Once you get to this stage, we need to take it algebraic. So before I start writing, kind of give you a break, but not a break. Like, we're going to set it up into a system of equations, an algebra 2 system of equations. However, I'm not going to make you do it by hand because that'll take you a lot of work by hand. So what I'm going to do is I'm going to jump ahead in the curriculum and use some calculator keystrokes, and then we'll talk about those later. So we're gonna jump ahead, but we'll use a powerful tool in there to figure it out. So this makes your life so much easier. So what you need to do. So one more time, let's get our head right. Okay, so we've got the crane. We've taken those vectors off of the crane and we've drawn it into a triangle such that it meets the vector of the weight of the object, 15,000 pounds down. We took our vector components, our x and our y, our horizontal and our vertical, our cosine theta, our sine theta, and we turned it into a real life application with tension 1. We used our angles and our values to look at that. So if we all do this with me, so if you all have your calculators in, I want you to go ahead and just do everything. Get everyone your calculators. I will do it on the screen, but the problem is that you cannot see the screen on the video. So we'll write it down. All right, so those of you that are in class, it's good. Those of you that are out. So most people are here except for Caleb. All right, so I need you to understand that what we're doing is, I'm not going to make you do this, but I do want you to understand that cosine of 223, make sure you're in degree mode. When I type in cosine of 23, that is a decimal point. It's actually negative 0.731. So that's the same thing as saying negative 0.731t, right? So it's just a number, right? That looks a little bit better, but you can do that or not do that. I highly advise you don't do that. What I'm going to do is put it in as a cosine function. So I want you to, we'll just do this. If someone needs some instructions later, they can come to me. So let's go over to the computer for a second. All right. So I need you to follow these keystrokes. You've never done this before, right? So the benefit of doing this is it makes a very difficult hand calculation very easy. All right. And actually next unit or so, we're going to actually do an entire unit on these, but I'm going to use a powerful tool from it and just show you how to do it. So what we're going to do is we're going to deal with matrices, right? And matrices are super powerful. They can, you'll take an advanced course in college called linear algebra. So a lot of your video graphics come from all this. Powerful, right? So what we're going to do is we're going to edit a matrix. Okay, and I want you to understand what's happening right now. You're going to be, I want to write up here, one of these pens. Right. So you're going to have, what did I say? You're going to have your, so you've got your cosine of your 223. And I forgot to tell you this. I forgot to tell you. Got to tell you a huge part. We've got to go back to the other screen very quickly. Go back to here. So if we're back to this over here. Okay. If those vectors are going to end up there, the resultant vector is the magnitude of this resultant vector right here. Oh, it's not drawing. There we go. The purple right there has a component of 0, negative 15,000. So what that means is when you add up these numbers, when I add, I'll do colors. So when I add the purple X or the red X to the green X, it needs to equal 0. When I add the red Y to the green Y, it needs to equal negative 15,000, because that's where your resultant vector is going to be. So now I can go back to the board. And I was going to say that we've got a system of equations that says the cosine, green word, cosine 223 plus the cosine of, what was the number? Negative 32 needs to equal 0. Right, that extra. And then the y component, remember this vector right here has got, it's right here. This vector right here has got a 0, negative 15,000. And when I start here and then drive down here, my resultant vector is like that. Okay, so if you weren't looking up here, one more time just for good sake. So the beginning to the end. So you add your vector, tip to tail, there to there, xy component, there to there, resultant vectors from the beginning of the first to the end of the last. My resultant vector has a component 0, negative 15,000. So those need to add up to 0. And my sine of 223 plus my sine of negative 32 needs to add up to negative 15,000. So that's a system of equations. Now, if you remember in Algebra 2, that's a decimal 0.731, whatever. What in Algebra 2, you would have to eliminate one of them or substitute. It's up to you, whatever Algebra 2 fancy you use. But most people would probably, I don't know. But you'd eliminate one, which means you'd multiply this by something to cancel these out. Actually, you have to set them up in a different row. Or you could substitute one in. So much work, right? What you're going to do is this next trick. So we're going to go in, and I'll put this back to the computer. So we're solving a system of equations set up appropriately. So now we go into here, and we set up a. You go into. Make sure. I'll start from scratch. Make sure you're there. You hit second matrix, which is the inverse key. And we are going to edit a matrix. So you go over to the edit column. And then hit enter. All right, and then what it's doing is sitting there. It's sitting there asking you, it doesn't matter what numbers you've got. If you've already been in here or someone that you borrowed the calculator from, whatever. If it goes in there, what's happening right now is it's asking you for, these are its rows. So this is matrix A. Man, these things are useless. Matrix A. Has anyone got any marker that works? Thank you. All right. Matrix A is going to be rows by columns. So my these are my rows. And these are my columns. So you're going to end up putting in 2 by 3. Okay, so you're going to put a 2 by 3. Yeah, I know the class before you did it, so I know we didn't have any classes between. Let me try and find. And I hope it didn't die. Oh, it's out of juice. Seriously. All right, so we're out. I will try and get this up as quick as possible. I'm out of juice. I plugged it in. But I want you to type in those numbers. I want you to type row 1, column 1. Well, actually, I don't know where you are yet. I'm sorry. Hang on 1 second. Sorry about this. Are you seeing anything yet? All right, good. Okay. So you've typed in 2 rows, 2, enter, 3, enter. So let me just get a quick check. Is everyone there? Okay. And then look what it did. It drew a matrix exactly that size. I want you to type in cosine of 223 into that one, hit enter, and it'll turn it for you. There's no reason to type in a decimal. I want you to put the rest of the elements in there, including the 0 in the 15,000, the negative 15,000 in the appropriate place. All right, so type them all in right now. So cosine, and then I want cosine of, what did I say, negative 32? And then that one's going to be a 0, so you can just hit enter or type it in, it's up to you. And then you do the sine of the same angle, so sine of 223. I'm going to speak to the people on the video, so I'm going to say it out loud. Now you do the sine of negative 32. And then you set the last column in the second row equal to negative. Now don't put minus, obviously, right? So you want to use the negative. So negative 15,000. 1, 2, 3. Hit enter. So make sure mine's slower than everyone else. So you're probably already there. Is everyone there? Anyone up there? All right. So now it's a bit of a pain. The coding's not very good. So what you have to do is you have to quit out. So second quit. Then go back in. Second matrix. And what we're going to do is we're going to do math on the matrix. So guess which tab we need? Not the name, not the edit, but the math. And then if you keep going down about 10 spots or so, 10, 11 spots, there's something, I'm doing it slowly because my... Okay. There's something called reduce rows echelon form. That's reduce rows echelon form. All right. So this is echelon as a person. It's a bunch of row reduction things that depends how far we get into matrices. We might do it. You're moving a bunch of rows around. Do not use the ref. You will get the wrong answer. It's reducing rows echelon form, right? And we'll see when we get into matrices. But this button will do everything for you. And if you're taking ACT this weekend, talk to me about it, and we can get some things showed to you. So we're going to do that. I'm going to reduce rows echelon form, and then it says, and now it wants to know what matrix do you want to work on. So it's like calling your dog. You have to go ahead and go into the matrix menu, and then you have to whistle its name. So like here, matrix A, come here, matrix A, right? There you go, plug them in there. And then you say, all right, off you go, do your job, and there it is. So you don't quite understand right now, and that's not important. 1001 is known as the identity matrix. We'll deal with that when we get there. Don't worry about that. What this means is this has solved the X component. It solved this, and this has solved this. Well, they worked in a system. So this means in cable 1, in tension 1, there's 13,169 change pounds of pressure in that cable. And in the second cable, there's 11,357 pounds. So for you to pull a 15,000 pound object up, you need what, 24,500 pounds pressure in the total in both cables. All right. So before we forget too much of that, you've got a ton of time. You're going to do one. So why don't you debrief? I'll shrink the screen up. Actually, I'll stop the video right now. Because you probably went the other direction. I'll have a look at it in a second. You probably drew it the other direction. The magnitude, the length, will always be positive. The components, the horizontal and the vertical components, can be negative, but the length has to be. So, but you probably just drew it up, or you probably mixed one of the angles around. Let me have a look for you.